Hello everyone, and thank you for attending today's webinar, Latest Advances Towards DOCSIS 3.1 Deployment, sponsored by Technicolor with a featured speaker from Comcast. Before we begin, I want to cover a few housekeeping items. On the right-hand side of your screen is a Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you today, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. Also, a copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open in your screen. Will only take 1 minute to complete. Your feedback is extremely helpful. Finally, an on-demand version of this webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Light Reading's Cable Video Practice Leader, Alan Bresnick. Alan?
Thanks, Hannah. Good day, everyone. Welcome to our latest Light Reading webinar entitled Latest Advances Towards DOCSIS 3.1 Deployment. My name is Alan Bresnick. I'm the Cable Video Practice Leader for Light Reading and a contributing analyst at Heavy Reading, which is the research arm of Light Reading. I will be your moderator today. Based outside Toronto, I specialize in the cable, video, and broadband technology markets. I put together this webinar in tandem with our exclusive sponsor, Technicolor, and our featured cable operator, Comcast. We have an excellent program for you today focusing on the rollout of the new DOCSIS 3.1 spec. In this session, we will review the main assets of DOCSIS 3.1, explain the benefits of the new spec, and update you on CableLab's D3.1 product certification efforts and MSO deployment plans. Then we will get into the meat of the webinar, delving into the market dynamics driving the development of DOCSIS 3.1, the new technologies that are powering it, the competitive environment, the challenges the new spec raises for MSOs, and the impact that it will have on cable access networks and home equipment. And we will hear from Comcast about their early deployments and the lessons that they've learned from those deployments so far. Okay, so first let me turn over to webinar logistics and how to optimize your experience today. Hannah's gone through most of these already, but I just wanted to show you this slide really quick. The key thing is if you run into any technical problems, please visit our webinar help guide by clicking on the help link below the presentation. And in addition, you can contact the technical support helpline, which is also located in the webinar help guide. Okay, so let's look at our 3 featured speakers today. We'll take a quick look. After I'm through setting the context for today's discussion, we'll hear from Srini Ramani. Srini is Director of Cable Broadband for Technicolor. He will join us today from Indianapolis. Next, we'll hear from Charles Moorman. Charles is Chief Architect for Connected Home for Technicolor, and he will join us from Lawrenceville, Georgia, outside of Atlanta. Last but definitely far from least, we'll hear from our old friend George Salinger. George is Vice President of Access Architecture for Comcast. He will join us today from Denver. Okay, before we get into setting the context, let me just run through the agenda for today. As always, we have a lot to cover in the next 60 minutes. I won't run through everything here, but as you can see, we're going to talk about DOCSIS 3.1 highlights and a status update. And then we'll get into the benefits of DOCSIS 3.1. We'll talk about what operators are expecting from it and what they're hoping to get from it, what the challenges are for cable operators in deploying DOCSIS 3.1, and also what the challenges are for the vendors in developing the equipment. We'll talk about what impact the new spec will have on both cable access networks, on equipment, and on the services that they can offer to their subscribers. And then we'll get the latest information from Comcast on where they stand with the deployment of DOCSIS 3.1 and some of the lessons that they learned. Finally, we'll take your questions as we always do at the end. So if you have any questions, please start lining up right now. It's going to be a pretty packed hour. Okay, let's go through DOCSIS 3.1 highlights. Again, a lot of you know this already. I won't run through everything here. The key, as you know, is the speeds that DOCSIS 3.1 can enable, up to 10 gigabits per second downstream and up to 2 gigabit per second upstream, depending on the network capacity. Right now, the initial devices that are out there already can support 4+ gigabit per second downstream and 1+ gigabit per second upstream. Other things to know about DOCSIS 3.1, which we'll get a lot more into in this webinar, is that it allows operators to have a fluid deployment strategy because of its backward compatibility with DOCSIS 3.0. It'll allow operators to reduce their costs of moving data across their networks because of the efficiency, and also allow them to use greater capacity over their existing HFC lines. Okay, not to mention the higher quality of experience. What's new with DOCSIS 3.1? We'll talk a lot about this later in the webinar. Let me just give you a brief overview, key technologies that not necessarily new technologies, but new to the cable industry, such as orthogonal frequency division multiplexing. Try to say that one fast. OFDM. Also forward error correction based on low density parity check, and a few other things, higher order QAM, and a few other things that our speakers will get into later on. The key thing to know about OFDM, though, is that it breaks the cable spectrum, the RF spectrum, into smaller portions that can then be bonded into much bigger blocks of spectrum, allowing for much higher capacity, much higher speeds. But we'll get a lot more into that later on. Okay. Status of DOCSIS 3.1 testing and certification. Cable Labs has been doing a lot of work on this over the last 4 years, as you can see, starting with the announcement of the DOCSIS 3.1 spec effort back in October 2012. Right now, Cable Labs is very heavily in the interops phase and the dry run phase. They just concluded a new interop phase last month, which is at least the 7th or 8th that Cable Labs has done since they started about a year and a half ago. They're also doing dry runs of equipment, getting them ready for certification testing, and they are also doing rolling certification waves whenever equipment is ready to go through it. So far, Cable Labs has certified 5 DOCSIS 3.1 modems, including one from Technicolor, our sponsor here, and they're hard at work on certifying others as well, so we expect to hear more announcements soon. My last slide here, talking about MSO deployment plans for DOCSIS 3.1, which we'll also hear a lot more about on this webinar. Here are some of the leading MSOs and their plans. The first one that we know of that's deployed DOCSIS 3.1 is Vodafone New Zealand, which started actually last November and should have concluded their rollout by now. The biggest one by far is Comcast. Comcast has started deploying, as George will tell us about later. They have one market, Atlanta, that they've done. They're about to go into Nashville, and they have plans to do at least 3 more markets in the second half of the year. We'll hear more about that later on in the webinar from both Technicolor and, of course, from Comcast. Okay. With that, I'd like to turn things over to our first main speaker today from Technicolor. He is Srini Ramani. Hi, Srini. How are you doing today?
Good. How are you, Alan? Good morning.
Good morning. Good morning. Please take us through your presentation.
Thank you. Good morning, everyone. Thanks, Light Reading, for this opportunity here to walk through some of the challenges and how the DOCSIS 3.1 is evolving, and also trying to go through some of the things from a CPE vendor perspective, purely how the development is coming along and what the operators are expecting, and how these things are all stitched together to make the things happen here. So to go into first thing is about the market dynamics. What is actually happening in the market and why the DOCSIS 3.1? Obviously, most of us know that speed war is happening. When you say speed war, it's kind of a little bit different in a way that it's not just the bandwidth availability alone in terms of how can we make the best user experience by allowing the better speed, and also how can we expand these bandwidth allocation into different services, how to make the triple play much more better. We all understand that there is no one platform that could fit everything, but there's a collection of things and services that adds these things. But at the bottom line, the baseline of it is going to be the availability of the bandwidth, and obviously the DOCSIS 3.1 is one of the mechanisms that can bring in. Of course, the bonding technology, obviously you had to bond those channels to make things happen. There is various things going on across the market, whether it is 10G or 11AC or DOCSIS 3.1 and iBeraccess, and across the networks, across the global actions. I mean, everybody is looking for this technology here. So there is a lot happening in the market to meet this speed requirements. So I think we switched. So what is that between why this DOCSIS 3.1? There is, obviously there is DOCSIS 3.1, which is able to give a certain amount of speed, but why DOCSIS 3.1? Obviously, one of the things DOCSIS 3.1 brings in is about 1 gig. 1 gig is becoming a baseline, and everybody wants to be on the 1 gig speed. Obviously, there's a lot of services that we'll talk about in later part of this section, is that how much this 1 gig is going to help us, why you need that 1 gig. DOCSIS 3.2 does solve a lot of problems in the past, but obviously looking at the characteristics of DOCSIS 3.1, it's higher QAM levels and higher speed rate, and also from an upstream perspective, one of the major things that brings in on DOCSIS 3.1 is bringing the upstream much more better. So that's one of the things that it's DOCSIS 3.1 becomes much more and more preferred. So in the market, obviously from a research perspective, we also understand that one, the market is looking at DOCSIS 3.1. Still, there will be some DOCSIS 3.0 till 19, but the ramp up of DOCSIS 3.1 most likely would start in 2017, and 2016 would be the likely year of initial lab trials, field trials, initial deployments, wherein the market would be testing the DOCSIS 3.1 equipments, and also understanding the market dynamics, how much is required, right? What is the speed tiers? What is that I need to be making the perfect product, the perfect model, the tier that I need to offer to have the better user experience. The challenges is the more on the gateway side, because of the fact that, it's get added up with much more Wi-Fi configurations, and that would add more complexity later part of, that's where the 18 and 19, much more gateway penetrations will be there. Very similar to the DOCSIS 3.0 market growth, where we have seen initial there will be DOCSIS 3.2 cable modem or EMTA, and later on the gateway penetration. It will be very identical. There will be initial DOCSIS 3.1 where we are seeing cable modems being much more preferred to understand the market, understand the network, preparedness, readiness of the network, those kind of stuff, and then later on kind of gateway market takes off. So obviously, some of the key benefits that we understand from a vendor perspective, from a CPA perspective, obviously this gives us a product that can give an ultra-speed broadband, right, up to 10 gigabits downstream or 1 gigabit upstream. Capacity on existing, obviously from a network perspective, a lot of savings are being brought into the operator, so this device is much more beneficial. Network efficiency or a spectrum allocation. The other major thing that would be very helpful, that what operators are looking at from a backward compatibility perspective, which is initially deploying these products in a DOCSIS 3.0 mode until the network is ready, so that the devices can be doing it. So the CPE vendor community, we are very focused on to make sure that not only the 3.1, the devices are being much more working seamlessly on a DOCSIS 3.0 mode, and convert them or transition them into a DOCSIS 3.1 when the networks are ready. Another major emphasis was given to the product while on development is the energy efficiency. So obviously that's been taken care of in this. So while we're doing it, there are a lot of expectations from the operator why the DOCSIS 3.1 devices are being much more getting ramped up. Is one of the things is about the services. We'll deal with a little bit more detail on services in the later slide. Mainly on the video side. Wi-Fi devices explosion that's bringing in much more video experience and video services now being offered through the IP, right? And one of the things that we see in the general market is every operator going on a full IP mode, at various stages. And one of the things we anticipate 4K would be taking off pretty much in most of these OTT-based services, and that requires a lot of bandwidth. So obviously that 3.1 is the solution at this point of time for the cable MSOs that's been looked at. And there are quite a bit of limitations in the terms of how can we do the current network? How do you optimize this network? And how do you want to make sure that we are offering what we are saying we are offering? That is another major challenge, and how to solve that one through the devices and as well as the network engineering. And least but not the least is the CapEx part of it. Obviously that is another major thing, is how can we minimize the CapEx investments that we are doing at the same time introducing this DOCSIS 3.1. So obviously the leveraging the existing network efficiencies, what's the network is offering today. So on that trend, what we are seeing more and more is about DOCSIS 3.0 networks being utilized to basically to make sure that we kind of introduce this DOCSIS 3.1 device at the same time, like make the network ready slowly and readily in the sense that to make it as a full DOCSIS 3.1. Just to be clear, there is like still we can run a DOCSIS 3.1 in an existing infrastructure. But to benefit the full efficiency of a DOCSIS 3.1, obviously there are certain changes. The challenges, I believe, later part, our friends will explain that one much more. So what's happened in 2015 and what to expect in 2016? So obviously we all understand DOCSIS 3.1 has been pretty hot cake right now. It's a lot of activities going on. There's quite a bit of things that happened in 2015, and there is a lot to happen in 2016. At the same time, the competitive technologies are also moving forward, and there's quite a bit of actions on that side too. I'll briefly touch on that one, not going deeper into that. So in 2015, obviously the SOC vendors, they start releasing much more of their mature SOC out. And early releases of silicon and also the units of vendor CPEs, we start having those CPEs start showing up in the labs and also for the cable lab certification processes. There's a lot of dry runs and interoperability tests happened throughout the year last year. By end of the last year, cable labs obviously started their cable lab certification process, and we were lucky to be one of the first devices to be there in the whole process. And in early part of 2016, the certification was completed, and we were one of the first devices to come out of it. We expect more and more to happen this year in terms of more dry runs, fine-tuning of the spec, more ECNs coming out. So that kind of maturing in terms of software side of the silicon to make it a full functionality complete. More certification. We expect more vendors to be participating in the certification process, as well as most of the operators will start their field trials. As we are seeing, there's a lot of requests coming in to have more products to be in the market so that we can be the full DOCSIS 3.1 out there. There's another topic that's been coming up. It's been in discussion. It's about full duplex DOCSIS, but it's very early phase in definition. For this seminar, probably we'll stick to DOCSIS 3.1. And obviously one of the major elements, not only CPE is part of it, but the CMTS is very, very important in this whole DOCSIS 3.1 evolution. We have been working as a Technicolor, we've been working with all the various CMTS vendors throughout the year, and we will continue to work on 2016 to make it a full, complete DOCSIS 3.1. Along with, obviously, with the Cable Labs and Excentis, which is the Euro Cable Labs division, it's doing a lot of work on making sure that the devices are working seamlessly across the network from end-to-end perspective. And obviously, as I mentioned earlier, we are one of the first vendors to secure a successful that goes through various CMTS configurations, various the features that were available as of today. During the certifications, we were successfully able to interoperate with those CMTSs. Competition technologies, obviously there is a lot going on. It's just kind of giving just a high-level overview. There are a couple of things from a telco perspective. What we are seeing is G-Fast is being very active on that one to compete, to bring closer to this one. Obviously, from a fiber perspective, there's a lot of fiber deployment from a GPON and EPON for the cable too. But there is really a kind of a competition. We believe that those will run in parallel, and then there will be a lot of challenges. But definitely from a cable perspective, we say that DOCSIS 3.1 would meet majority of the user needs for the bandwidth and the speed requirements that can give the best user experience here. So what is the general operator challenges? I think it's kind of rehashing a little bit what we talked in the earlier of expectations, but one of the major thing that, what we have seen is, the DOCSIS 3.1 introduction will depend on network evolution. When I say in the network evolution, it talks about generally what is the upstream split is going to look like and how the frequency, the allocations within these things, it varies from vendor, operator to operator, and where they have an FM QAM channels or any other channels within that one, how they would kind of benefit or realize the full DOCSIS 3.1 benefits. So it's going to evolve over a period of time, but at the same time what we believe is there will be a limited deployment on DOCSIS 3.1, realizing some of the benefits of DOCSIS 3.1 on existing network as the operators are moving, modifying the network to make it a full DOCSIS 3.1. So that's where there could be several steps to be taken from an operator perspective to make it a full DOCSIS 3.1. It's going to be an evolution process. We'll touch a little bit on that one during the exercise, what we have seen from a Comcast perspective, and I think George might be covering some of those. From a rollout effects, this gives a little bit overview on what from an Technicolor perspective, what we are seeing, what based on the information that we receive and what the researches that we have done is where is the market it's going on pretty heavy right now. In fact, I can make it as in a single statement there across the globe. In a sense, like every operator out there in the cable space across the globe, across each of the regions, really wanted to go for DOCSIS 3.1. But it all depends on it's kind of varying stages in the sense where their networks are, what's the financial situations that an operator is in. A lot of factors weigh into this. But however, there is very limited deployments being has already started in some of the North American customers, and we see that one majority of the North American customers would be having their first deployment happening this year, and most likely some of the European operators would be having their first devices in the network with the DOCSIS 3.1 by end of this year. So predominantly this year is a year of DOCSIS 3.1. It's going to be very active, and we are very excited that we are part of that challenge journey. So obviously, what are the next steps? There's a lot of things going on with the DOCSIS 3.1 from a previous slide where this market is pretty active. Obviously, cable labs will continue to do this one from a DOCSIS 3.1 perspective, fine-tuning it. And there's going to be a lot of pressure and need for DOCSIS people for to have these devices out there, and we are pretty much ready for it to take that challenge and be a part of the DOCSIS 3.1 evolution. The devices and sorry, next one slide. Sorry. Okay, so where are we on that one to meet those kind of challenges? Obviously, we have a different portfolio of products in our bag, which is from a cable modem, a simple wired cable modem, all the way to gateways. Like I said, the cable modems will be the initial ones for field readiness, network readiness, initial DOCSIS 3.1 technology learning, all kind of stuff, which is what the cable modems will be mostly used in the labs in the very limited field, and then pretty much move to a gateway. We have been engaged with several operators with preparing the samples and offering those field trial support to make sure that they are ready for DOCSIS 3.1. At the same time, gateway samples are getting ready because of the challenges in terms of the overall system, in terms of Wi-Fi, in terms of MoCA, or in terms of the whole system solutions perspective. The gateways are a little bit taking more, is following behind cable modem. But we are pretty much, we are in fact I see most of the other vendors or the CPE vendors would be following suit, which means that the gateways will be there in this year of 2016. So with that one, I hand it over back to Alan.
Excellent, Srini. Thanks very much. That was extremely comprehensive. Now let's turn to our audience poll question today. Please take a look at your screens. Here's the question. The question is, when do you plan to upgrade your cable systems for DOCSIS 3.1? 6 choices we give you are, we have already done so, by the end of this year, 2017, 2018, 2019, or beyond. And finally, we have no plans to upgrade to DOCSIS 3.1. Now, as always, it'll take a few moments for the ON24 system to collect all the results, So if you want to ask any of our speakers a question while you're waiting, just type your query into the Ask a Question text area and then click the Submit button. Okay, in the meantime, let's bring Srini back for a quick question here. Srini, what are the challenges for developing DOCSIS 3.1 CPE for vendors?
That's a good question, Alan. One of the major challenges we see is the SOC maturity, and also the other one is the system-level testing of that to validate the DOCSIS 3.1 feature set. Because of the fact that there are various devices and everybody is bringing up and doing the development, it becomes challenging. Unlike a DOCSIS 3.0 or a DOCSIS 2.0 days, this is becoming much more difficult to spin around quickly. But however, nevertheless, there is a necessity there. Everybody understands the urgency of DOCSIS 3.1. It's coming up pretty quick. We could get that one to level of comfortness, I would say, to release it to the field. So,
okay. So the chip vendors are the biggest issue right now.
I wouldn't say chip vendor. It's the maturity that everybody is developing and validating the system level performance to make sure that we meet the quality and for the release. That has been a challenge over the 2015, and I think we have been overcoming that one as we speak, which is kind of resulting in devices being seen today, field trials successfully, and getting ready for launch in 2016.
Okay, thanks very much, Srini. Let's take a look at the results. Almost a tie. By the end of this year was leading choice so far of 30% of you, and next year, 2017, is 28%, so almost 3/5 of the audience say that they're going to be rolling out DOCSIS 3.1 by the end of 2017, and then another 14% say they're going to do that in 2018. So as Srini says, it does look like it's going to be the year of DOCSIS 3.1 this year, and next year will also be another year of DOCSIS 3.1. Okay. Well, thanks, everybody, for participating in the poll, and thanks again to Srini. Now let's turn things over to the second part of Technicolor's presentation, and I'll bring in Charles Moorman, once again from Technicolor, for his presentation. Good day, Charles.
Good day, Alan. Thank you, and hello, everyone. I wanted to spend just a few minutes on what are some of the things that DOCSIS 3.1 enables, what's driving that growth, and what are the impact on the CPE, what is the impact on the home networks. So we've heard a lot about the higher bandwidth supported by DOCSIS 3.1. And one of the things we get from that higher bandwidth is flexibility. So a number of operators are talking about in the future they'll use part of this bandwidth to actually deliver end-to-end IP video. So today on cable networks, whether it's linear broadcast, switch digital, or VOD, a lot of the services have traditionally been deployed on QAM. And with DOCSIS 3.1, we have the bandwidth, or operators have the bandwidth, to be flexible, to use IP video for all three of these services. IP video enables a lot of different options. Again, it's about flexibility, whether it's new codecs, new DRM supported, new video formats, higher resolution, a lot of advantages for IP video because of that inherent flexibility, whether it's a unicast distribution or a multicast distribution, just a tremendous amount of flexibility that this higher bandwidth enables. That's not to say that QAM is going to go away. QAM will certainly still be on the cable plant for the legacy homes, but at least for new homes and new CPE, we have new options, and those are very exciting. Of course, the other things that always drive bandwidth growth are new services like video conferencing, home security cameras, also new interest in new services like virtual reality. Every time we look at new services, they really add to the bandwidth on the pipe and provide some motivation for operators to drive that a little bit higher each time. And of course, there's always the bandwidth war, the competition with other operators to offer a premium service tier. So when we looked at the effect on CPE, of course, the DOCSIS modem or DOCSIS gateway itself does transition. DOCSIS 3.1 requires new silicon and some new options. One of the things that a number of operators are looking at is flexible diplexers or software controllable diplexers on those modems or gateways. Whether that be to move the split from 5 to 42 up to 85 or 208 or even potentially higher in the future. The flexible diplexers under software control actually allow you to deploy CPE today that can be changed in the future to support different splits and different allocation between upstream and downstream frequencies. The effect on set-top is really driven by the potential for end-to-end IP video. We're seeing a lot of new interest in Wi-Fi set-tops, for example, because of the new video formats that will be available given the DOCSIS 3.1 bandwidth. Set-tops won't necessarily have to attach to the cable plant. They won't necessarily have to receive QAM. They can be attached via Wi-Fi, via MoCA, or other options as well. So again, higher bandwidth driving or enabling a lot of new flexibility. So the other thing we look at, of course, is what is the effect on the home network itself? Well, gigabit Ethernet is becoming a bottleneck. As you drive the DOCSIS 3.1 speeds to multi-gigabit, the traditional way of connecting a DOCSIS modem to an external router gateway via a gigabit Ethernet link becomes a bottleneck. So that's driving, I would say, a lot more interest in integrated DOCSIS gateways that don't have that bottleneck, that can provide gigabits or more than 1 gigabit speeds, either via Wi-Fi or via a combination of multiple Ethernet ports. There is also an option to support 2.5 gigabit Ethernet or 10 gig Ethernet, although these are not widely supported today, at least in the CPE environment, but that is an option that will be coming in the future. And of course, there's also an increased push for faster Wi-Fi, whether that's 11AC going to 4x4, or in many operators we're seeing interest in 8x8 modes. Again, it's higher range, it's higher rates, it's pushing the bandwidth in the home to keep up with what's available coming into the home. And of course, over the next few years, we'll also see the introduction of 802.11ax. That's going to take a little while, especially when we talk about deployment. So we're probably in the 2 to 3 year horizon for 802.11x, but that's would yet again increase the bandwidth. So Alan, let me turn that back over to you and let you introduce the next speaker.
Okay, very good, Charles. That was fascinating. I'd love to do another webinar where we just talk about the impact of DOCSIS 3.1 on home equipment. I think that would be great for the audience. So thanks for those insights. Now let's get the latest on Comcast DOCSIS 3.1 activities from George Salinger, who's one of the spec's great and early champions. Welcome, George.
Thank you, Alan, and good morning, everybody. At Comcast, we have been working on DOCSIS 3.1 deployment, development and deployment for quite some time. Our goal, as outlined in this slide, has been and continues to be to deploy DOCSIS 3.1 as quickly as we possibly can over our existing HFC network. To do so, we worked on accelerating DOCSIS 3.1 technology, as we did with DOCSIS 3.0. We did that by maximizing the use of the functionality or maximizing the development towards the use of the functionality that we really needed, and minimizing the development in areas that were not needed at the moment. And so we focused on deployment of DOCSIS 3.1 in the downstream so that we could offer a gigabit per second service. In 2015, we worked towards preparation for DOCSIS 3.1 deployment. We focused, as I said, on the required functionality, both on the CMTS CCAP platform as well as on the cable modem/gateway. We did a lot of equipment testing, field operations of OFDM, development of tools, training, etc. And then we'll add features as the development of the functionality becomes available. We have trials underway in Philadelphia, Atlanta, and in 2 locations in California, and we have deployments now underway. In terms of field testing, one of the areas that we did a lot of work on is verifying that OFDM signals at these high modulation orders as DOCSIS 3.1 supports will work effectively in the field. And so we focused on testing HFC signals in all forms of networks so that we could verify that they indeed did work. And so we did testing in 750 megahertz systems, 860 megahertz systems, and 1 gigahertz systems. We transmitted 1,024 QAM and 4,096 QAM signals in the downstream direction using a signal generator. We didn't have at the time that we started doing this testing a DOCSIS 3.1 cable modem and CMTS, and so we used a signal generator that can produce signals of this, this kind. The signals that we produced were actually true, complete DOCSIS 3.1 signals that were demodulated and decoded on the receiving side, so we were able to measure modulation error rate and other features. We saw across all of the systems that we tested better than 37 dB MER in all homes, and this includes testing after long cascades of amplifiers. We tested up to 6 amplifiers in cascade, and we found very little degradation on the signals, in a cascade of amplifiers as we would have expected. The picture that is shown here is a true 4096 QAM signal, including in faint yellow the pilots and all of the components of the signals. One of the reasons we focused on doing this testing is so that we could understand what are the optimal modulation profiles that we would use in each part of the plant and in each plant type. DOCSIS 3.1 incorporates this feature of a modulation profile where a channel, which is much wider than a current 6 megahertz channel, that can be up to 192 megahertz, can be configured in different parts of the spectrum with different modulation profiles and with different modulation orders, and we call that a modulation profile. Not only did DOCSIS 3.1 define the modulation profile, so we don't have to modulate an entire channel in the same way, but it also defined multiple modulation profiles so that we can talk, so the CMTS can talk to different groups of modems, even on the same service group with different modulation profiles. To do that, the DOCSIS 3.1 specification allowed cable modems to not have to listen to every communication of the CMTS like we have done in the past. In the past, in all previous versions of DOCSIS 1.0, 1.1, 2.0, and 3.0, every modem had to listen to every transmission of the CMTS in order to maintain, for example, synchronization, timing synchronization, and to know when it is his turn to receive data. In DOCSIS 3.1, we separate from that modality so that we can communicate to each cable modem in the best possible method without having to configure the entire network for the lowest common denominator like we've done in the past. That practice has worked very well in cable systems, but it has left data on the table, if you will. We would have been able to transmit more data to some of the modems faster, leaving more time in the wire to communicate with other modems. So in DOCSIS 3.1, we added the concept of the modulation profile and the concept of multiple modulation profiles so that we can communicate with different modems in the most optimal way. And we found that in some cases, we see this picture that we have here is one that we've looked at over some time, over quite some time, where the picture represents a distribution of signal-to-noise ratios for different population of modems. And so we found this picture to be actually representative of what we find in the network with a higher modulation order. So as we tested in different places, we found some locations, in all locations we were able to transmit at 1,024 QAM with extremely low bit error rate and no bit error rate in many cases. We did very long periods, testing for very long periods of time to make sure that we get bit error rate, accurate bit error rate measurements over long periods of time. And we found very little to no bit error rates with 1,024 QAM. With 4,096 QAM, we found that we're not able to transmit to all the modems in the plant at that modulation order, but that is actually what we expected. And so one of the reasons we did this testing is so that we can determine what's the most optimal modulation profile, not only so that we know how to set up the cable modem, but so that we can tell the cable company, the equipment companies that we work with to focus their testing on those modulation profiles so that the equipment could be available quicker. In addition to that, one of the things that we found as we were testing in the field, we didn't expect this, we should have expected it, but we didn't expect this. We found it sort of by chance, is that DOCSIS 3.0 cable modems understand DOCSIS 3.1 signals, even though they don't understand them. This picture shows how a DOCSIS 3.0 cable modem in the top is seeing the spectrum. This is a full band capture cable modem that can see the entire spectrum in the band from the entire downstream band. And when we introduce the DOCSIS 3.1 signals, as is shown in the picture below, this cable modem, 3.0 cable modem, can see these 3.1 signals. And so one of the things that we are able to do with this functionality is, as we deploy in the cable system DOCSIS 3.1 signals, we can use the feedback from the DOCSIS 3.0 cable modems to know how well these signals are propagating through the network. This is a very interesting thing to find out, since we have so many of these cable modems deployed. We have millions of these cable modems deployed, and we can use them very effectively as a spectrum analyzer in different parts of the plant. We announced that we were going to start doing field trials around the July timeframe. This press release is from July 24th, and later on in the year, in the November timeframe, we started deploying, and we announced on December 22nd that we had deployed cable modems. By the time we did this announcement, we already had several cable modems. We didn't just have one. We had about 100 cable modems deployed across the network in the different locations that I mentioned before. Just recently, about 2 months ago now, we announced that we will introduce DOCSIS 3.1, and we announced the areas and the time frame, and so we started doing that just recently. We are now deploying in the Atlanta region, and we'll soon be deploying in Nashville. We'll do both of these. We already have customers in Atlanta, and we're still deploying in Nashville before the middle of the year, and we'll deploy in Chicago, Detroit, and the South Florida area in the second half of 2016. Our first customer installs have been completed, and we have now customers active in the network. So with that said, I'll turn it over back to you, Alan.
Thanks, George. Thanks for bringing us up to date on Comcast and all the great insights. A quick question for you: are there any surprises from early deployments from the tests? Anything that you didn't expect that's happened?
No, I mean we did expect. I mean, a couple of things that may not be. We've been working on this for about a year now, right? So there's very little that we didn't expect, but still a few things are important to recognize. One of them is the customers' computers are not all going to be ready to support these kinds of speeds, and I think all operators that are deploying gigabit or multi-gigabit services as we are finding the same thing. And so one important interesting thing to keep in mind is that when an installer goes to a home to install a service, the installer should be ready to demonstrate that the service does work as intended, despite the fact that the customer's equipment may not support it. Another important aspect to keep in mind is training. I mean, I think we all know that training is a very important thing, and that our staff needs to be prepared to support customers that sign up for these services. In general, the customers that sign up for these advanced services are the most advanced customers, and they are going to have usually questions that could exceed the expertise and the ability of our organization as a whole, and we need to be prepared for that. And I think we have done so. The other thing, in particular to cable systems, is understanding that these signals are new, and how to operate them, and how to configure them, and how to manage them, and how to monitor them. And so for that, we use tools to automate the various steps. And it takes time to get those tools ready to support a service of this kind, because of the difference in PHY and the way we transport the signals, because of the differences in capacity, because of the differences in utilization. So there are things that one needs to be prepared for. But no, we haven't found anything that has surprised us today. And if anything, the thing that surprised us is that it works so well.
All right. That's a good surprise to have, right? Okay. Well, thanks very much again. All right, that concludes the more formal part of the webinar. Now it's time to tackle your questions. So let's see what we have in the queue so far. As a reminder, to participate in the Q&A, just type your question into the text box located below the media player, and then click the Submit Question button. Okay, so the first question we have on the lineup here is, what's the most important first step towards implementation? I think that could be both the Comcast and the Technicolor people. Who wants to go first?
I covered a few of them. I don't know that there is a particular order of things, but as a cable operator, I think one important thing to do is to test how the signals work in different parts of the network so that we can establish what's the most appropriate modulation profile to use or the most appropriate modulation profiles to use to maximize the use of the capacity in the network. Another is monitor utilization on the network to make sure that that as more and more subscribers are added, that we're appropriately managing capacity in the network. Another one would be speed testing. Speed testing is perhaps the prime application for this kind of service at the moment. So many people point out, there is very little that you can do these kinds of speeds, and I think that is something that we're all finding because it's actually true. And speed testing is one of those things that will be used, and so having the appropriate infrastructure to support speed testing is another thing to prepare for, because as over the cable systems and other forms of transport, we've supported lower speeds before. We didn't have to worry about a speed test that runs at 1 gigabit per second, and now we do. So there's many areas like that. I don't know that there's any particular order to them.
Okay, thanks, George. Srini or Charles, did you have anything you wanted to add?
Yeah, so from a vendor perspective, I think George covered most of the field-related thing. From a vendor perspective, one of the things we normally see is to have an early lab trials and the readiness testing. That's what we've been engaged from a Technicolor perspective. We've been engaged with several operators to do some readiness. There is no one-size-fits-all kind of solution on this implementation that we can draw out because every environment is a bit different. So we had to go through that exercise to make the implementation correct or take the first step.
Okay, thanks, Srini, and we're looking forward to hearing which operators you're working with. I'm sure you're looking forward to telling us about it. Next question is, how can cable operators make DOCSIS 3.1 modems work with MoCA 2.0 devices when they may be overlapping on the same 1.2 gigahertz bandwidth?
So I'll give you an operator perspective on this. We use MoCA very extensively, and so far we have decided to not use the spectrum above 1 gigahertz in our cable modems.
Okay.
One way to deploy them is to a single port device that would have to support both MoCA and DOCSIS signals on the same RF port, and that's what we're deploying at the moment. And so we've chosen to not use the spectrum above 1 gigahertz. And the reason for that is because we have very little planned that supports spectrum above 1 gigahertz, up to 1.2 gigahertz today. The other is we have a considerable amount of spectrum below 1 gigahertz that we can use for DOCSIS 3.1, so we don't really need to use a spectrum above 1 gigahertz. Eventually we will want to use it, and so at that point, the way to do that is by having a two-port device, meaning that the RF WAN side will connect to the HFC network and will support up to 1.2 gigahertz. On the other port, you would use MoCA for the network inside of the home. If you're using MoCA for the network inside of the home, you would use it out of the second port, and then you can use MoCA to its fullest extent without worrying about what parts of the spectrum does one use versus the other.
Interesting, George. How far in the future do you think that is?
I don't know. Spectrum capacity keeps on growing, has been growing. At a capacity in terms of utilization and service offering has been growing at a rate of 40 to 60% year over year. There's no evidence to substantiate that there will be a change, but everybody agrees this can't continue forever. But who knows? If it does continue to grow, we should be using the spectrum above 1 gigahertz within the next few years, and we are deploying networks that are capable of 1.2 gigahertz already.
Okay. Srini or Charles, anything to add to that?
No, I think George answered more so because he's one of the most widely deployed MoCA-based environments. So, now for us is from an equipment perspective is obviously we want to support either of the cases in case there was a need for going in and beyond using up a MoCA channel. So our devices, we trying to say, okay, cap it at 1 gigahertz on the top edge, and so that it can be well utilized. And if there is a need for certain markets where there is no MoCA or we need to be used, and we can go all the way up to 1.2. So there is different ways of variants that we offer to meet these demands.
Okay, very good. Let's move on to the next question. This one has to do with OFDM. I figured we'd get a question about that. How wide an OFDM channel is being used in the early deployments of DOCSIS 3.1? Is it a full 192 megahertz wide, or is it smaller than that?
In our initial, this is George. In our initial deployment, we're using half of a block, 96 megahertz. Mm-hmm. As we add more users and as capacity or as utilization grows, we will expand to a full block, so doubling what we have deployed so far. As utilization continues to grow, we can add a second block, so we can quadruple what we're deploying now. And that's that's the extent of what a first-generation modem will support. First-generation modem will support, as I think we've covered before, 32 single-carrier QAM, 3.0 channels, plus, which is 96 megahertz, plus 2 blocks of OFDM, 96 megahertz. One 32 channel block is 192 megahertz, plus 2 OFDM channels at each one at 192 megahertz. So one first-generation modem will support 96 channels, or 3 times 192 megahertz of spectrum. So it's a lot of spectrum compared to what the modems that we have deployed so far. But to answer the question, we start with 96 megahertz. We can double that to 192 megahertz, and then we can add another channel allowing us to double that. And then there will be a next generation DOCSIS 3.1 cable modem at some point in the future.
Okay, thanks, George. Let's go on to the next question. Can you give us?
Alan, let me suggest. There's several questions about cost. We can't quite comment about cost. None of us can. But let me say this generally, at a bit of a high level.
Sure.
What is the relative cost of DOCSIS 3.1 versus fiber to the home? It's
that was my next question for you.
Yeah, it's significantly cheaper, and that's a reason why I think all cable operators are going to deploy, or the majority of cable operators are going to deploy DOCSIS 3.1 because it offers significantly more capacity, multi-gigabit service capacity. Without having to incur a lot of cost. It doesn't cost that much, and without having to change the topology of the network. The topology of HFC networks has evolved over time to smaller service groups and more spectrum, right? We expanded in both dimensions. We reduce the number of subscribers in a service group, make the service group smaller, and we add spectrum. And HFC networks continue to expand in both of these dimensions, and DOCSIS 3.1 will allow us to support, of course, up to the full spectrum if we wanted to do that, if we removed all other services, which is a direction that we're, in general, cable operators are moving to as we start deploying all our services over IP. At Comcast, we started doing that already. Eventually, we'll offer all our services over IP, and when we do that, we can allocate the entire spectrum if we wanted to on a per service group basis, for however small that service group is at the time, which can get really very small, and offer multi-gigabit services over the HFC network. So significantly cheaper, does not require us to change the network, does not require us to do any construction on the streets, deploying fiber, even though we do that. We do that very extensively. We deploy fiber in all new build, but in places where we have the HFC network, we don't have to change the network, we don't have to tear up streets or customers' backyards in order to deploy multi-gigabit services.
Okay, so stick with your HFC plan then.
Yeah, and hi, Alan. This is Charles. I was just going to add on to that. Thanks, George. I completely agree. I just want to also point out that DOCSIS 3.1 is not an all or nothing proposition. There's so many different benefits to DOCSIS 3.1. Whether it's increased or better use of spectrum, or freeing up new spectrum, or moving spectrum from downstream to upstream. And operators don't have to consider that they have to do all this together. They can begin to introduce DOCSIS 3.1 just to take advantage of one or two features, even if it's just, as George said, to get started with a half a block of OFDM, because DOCSIS 3.1 will make better use of that spectrum than DOCSIS 3.0. So it's really not an all or nothing, and that lets operators begin to deploy very, very efficiently.
Okay, thanks, Charles. Here's probably a quick question. Will 2.5 gigabits per second be a real option, or will you think it will be better for cable operators to just go right up to 10 gigabits per second once they go beyond 1?
Yeah. Hi, Alan. This is Charles. I think that applies to the home network bottleneck question.
Okay. I wasn't sure. Thanks.
Yeah, it didn't have the context, but if I'm assuming it's applied to that home network. So we're expecting to see 2.5 gigabit per second coming out first. I think that'll be available before 10 gig, at least in the CPE. 10 gig will be available at some point in the future, but is initially going to be a higher cost. Even to get to 2.5, I think we're probably at least a year away because there is some silicon change that's required for generally to get to 2.5, whether that's in the DOCSIS 3.1 modem or in the devices that you'd want to connect to in a home. There's very few devices in the home that support a 2.5 gigabit per second Ethernet connection today. So it's going to be an evolution, but I think both will be viable.
Okay, thanks, Charles. Okay, we have time for a few more questions before the end of the webinar, but before I ask anything else, I just want to point out that I've pushed an evaluation form onto your screens. Please complete this form so that we can get some feedback about what you liked and what you didn't like about this webinar. Please also tell us what you'd like us to cover in the future. To complete the form, please press the Submit Answer button on the bottom of the page. Thanks. Okay, while you're completing the form, I'll go ahead with some more questions. Here's a question probably for George. George, what is the size of Comcast's service group for a 3.1 deployment?
So it's the same service groups that we have today. We haven't changed the service group topology because of the deployment of DOCSIS 3.1. As Charles was saying just now, you can begin deploying DOCSIS 3.1 in the networks that you have today and start taking advantage of the features that DOCSIS 3.1 offers. We have not changed the topology of the HFC network in order to deploy DOCSIS 3.1. We have not changed it in the places where we deployed it, and we're not planning on changing it in the places we're deploying. Now, having said that, we're always improving the functionality and the capabilities of the HFC network. All operators do that. Well, we always try to improve how they work, and so we improve how they work in several ways. As I said before, one of them is, which we have been doing for years, is make service groups smaller and smaller. We do that to increase the capacity of the network so we can support more users with the same amount of spectrum. We also increase the spectrum that we have in HFC networks. Over the years, we've gone from systems that were a few hundred megahertz to systems that are over a gigahertz now, and so those are two dimensions in which we can change the capacity of the network. But no, we have not changed the capacity of the HFC network or the number of customers or subscribers in a service group for deploying DOCSIS 3.1. We use the same service group capacity that we had before.
Okay, and Technicolor folks, are you seeing that from your other customers as well? Are they changing the size of their service groups or using the same size?
So,
yeah, go ahead.
So at this point, I think that the model is very similar to what George is following, pretty much using the existing ones. And like I said, as they are learning, as they are going through the exercise of network readiness, that there are a lot of things that people are doing. At this point of time, everybody is at the very early stage of trying to use the same service groups. And we believe that it would be there for some, at least for the initial deployments, and move on for different service groups as they see needed.
Okay, thanks, Srini. Let's move on to the next question. Will the cable modem add a speed test capability to be able to demonstrate throughputs over 1 gigabit per second? And how do you demonstrate speeds over 1 gigabit per second to the customer?
So let me try to answer that, and the folks from Technicolor may want to add some. So we are today using a separate tool in order to do speed testing. We do that in both the employees' homes, where we have been doing in the initial testing, as well as in customers' homes. And where we did the initial testing in employees' homes, we use this device called the Banana Pi that allowed us to do continuous testing, automated continuous testing. It is capable of running a test at a gigabit per second. The network was set up to support a gigabit per second, and so that tool gave us a lot of information on how reliably we were able to support a gigabit per second. And of course, we found that we optimized the network in order to provide very reliable capacity. Now, as we move into installations, we use other tools. This device is very good for us to get information, but it doesn't give information to the customer. So our installers are equipped to run a test that demonstrates, using a computer, that demonstrates that the performance of the network supports a gigabit per second. You could use the same devices to execute tests that will run at faster speeds. We have not yet deployed over the HFC network speeds faster than a gigabit per second, but we do that over fiber. We have been deploying a 2 gigabit per second service for quite some time, and we do have equipment similarly that will do tests of that kind. So that's what we have been doing. We are now working on tools to do internal testing on the cable modem. We've not finalized that. We don't have it ready for deployment, but it would be very useful because it would allow us to run, speed testing. It would be very useful for us and for customers. It will allow us to run speed tests without doing anything in the customer's home. To some extent, it's similar to traditional loopback tests where you are able to test up to the termination point to make sure that it works properly independently of what happens in the customer's premise. So we are working on that, not ready yet, trying to figure out how all the ins and outs of how that would run, and that would allow us to run speeds that are faster than the interface of the CPE will allow. The CPE in itself is limited to a gigabit per second in its Ethernet interface, so I can't run any faster than that until we have faster speeds like 2.5 gigabit or 5 gigabit per second interface. So hopefully that gave a complete answer. Sorry that it took so long.
That's okay. We have time for one more question. Let me ask this one. How would virtual CPE interact with all these higher speeds that the hardware demands?
In the same way as we have been working on – oh, go ahead, Charles.
No, go ahead.
So in the same way as with other services, as we virtualize parts of the network, which we're working on, we can virtualize parts of the CPE devices that we use. And so in the same way as we can virtualize, for example, commercial services, which we're working on, we can do the same thing with residential services. In the same way that this would apply to fiber-based services, it would apply to DOCSIS-based services. So we are working on virtualization of the functionality in the CPE with DOCSIS 3.1 as well.
Okay, very good, George. Anybody from Technicolor want to get the last word in on that?
I was just going to say that, it certainly can be supported. I think one of the challenges in virtual CPE is scaling that virtualization. If you move the home router to the cloud, for example, and we drive the residential broadband speed to multi-gigabit, we have to be aware of scaling that cloud virtualization to support these faster speeds. Pushing this speed envelope faster, you just have to make sure that the entire network can scale, including any virtual CPE portions as well.
Okay, thanks, Charles. I think we're going to have to make that the last word. Thanks, everybody, for getting in your questions. If any of your questions weren't answered, the speakers will be getting them all afterwards, and they'll be able to respond to you later. Okay, so I'm afraid that we've run out of time, but I'd like to thank everyone out there for attending, and I'd like to thank our three main speakers, Srini Ramani and Charles Moorman from Technicolor, and George Salinger from Comcast, for sharing their insights with us today. As Hannah mentioned, this webinar will be archived on the Light Reading website by the end of this week. Within the next 24 to 48 hours, you should receive a personalized follow-up email with details and a link to today's presentation on demand. So please feel free to review the webinar whenever you like over the next 12 months. This webinar is copyright 2016 by Light Reading, LLC. The presentation materials are owned or copyrighted by Light Reading, Technicolor, and Comcast, respectively. These three companies and their speakers are solely responsible for their content and opinions. On behalf of Light Reading, Technicolor, and Comcast, thanks again for tuning in today. Take care, everybody, and have a great week.
Thank you.